Welcome to the Explainer. Today, we are unpacking the complete 2026 blueprint of 15 essential MLOps engineering skills. You know, if you've been watching the rapid evolution of artificial intelligence lately, you already know that building an AI model, well, that's really only half the battle. So today, we're breaking down exactly what it takes to bring those models out of the lab and into the real world, using a highly structured blueprint derived straight from industry-leading training materials. Let's get right into it.
Okay, think about it like this, and I love this analogy from our sources. Building an AI model is exactly like designing a concept car in a high-tech garage. I mean, it looks amazing, right? It's completely cutting edge. The data scientists have spent months meticulously tuning the algorithms so it performs flawlessly in a beautifully controlled environment. But right now, it's basically just a prototype sitting quietly behind closed doors.
But here's the catch. We have to ask ourselves, what happens when everyday people actually need to drive that car every single day on real, unpredictable roads? What happens when it faces unexpected traffic, changing weather, or needs a sudden repair while it's zooming down the highway at 70 miles an hour? That is the exact massive challenge businesses face today as AI moves from small test projects right into everyday operations, like banking, healthcare, and online shopping.
Enter MLOps, or Machine Learning Operations. This is the absolute game changer. MLOps provides the testing, the maintenance, and the rock-solid system infrastructure to keep that AI car running safely in production. It is this vital, powerful combination of machine learning, DevOps, cloud computing, and automation, because without it, companies end up wasting massive amounts of time and resources trying to maintain models that ultimately just break under real-world pressure.
So, to make sense of the 15 distinct skills you need to master this, we've organized the blueprint into 4 distinct phases: the foundation, the deployment engine, the dashboard, and finally, the career path. And this breakdown brilliantly illustrates the difference in roles. While data scientists are the ones building the engine, you, the MLOps engineer, are the one keeping it running safely on the highway. For instance, a data scientist might create a fantastic product recommendation algorithm, but the MLOps engineer is the person who ensures those recommendations actually load instantly for millions of users and update seamlessly the second new products are added.
All right, kicking things off with Phase 1, the foundation, focusing on code and data.
Before you do anything else, you've got to have a rock-solid toolkit. First up is Python. It is literally the most important language for MLOps, the absolute backbone for your scripting, automation, and data processing. Second, machine learning knowledge. You don't just deploy the models, you need to understand how supervised and unsupervised algorithms actually work before you release them. Third, data engineering basics. You need to know how to build clean data sets and do some feature engineering to get better performance. Add in Git and GitHub for tracking your code changes and team collaboration, plus a solid grasp of basic Linux commands since most cloud servers run on it, and you've got your foundation.
Moving right along to Phase 2, the deployment engine.
Now, this is where the rubber meets the road. You need the right tools for the right jobs to ensure your model runs consistently everywhere. We're talking about using Docker for containerization, which packages your apps and all their dependencies up securely. Then use Kubernetes for orchestration to automatically scale those applications up if traffic suddenly spikes. And of course, cloud platforms. You'll need to learn AWS, Microsoft Azure, or GCP, because let's face it, almost all production ML models are hosted on cloud infrastructure today.
But how do you tie all those amazing tools together? That's where CI/CD comes in: continuous integration and continuous deployment. By mastering tools like Jenkins and GitHub Actions, you automate the testing and deployment of your models. That means faster, incredibly reliable releases, completely avoiding those late-night panic sessions when a manual update accidentally breaks the live environment.
Once the model is live, we hit Phase 3, the dashboard. This is all about managing and monitoring.
You have to keep things highly organized here. You'll leverage specialized tools like MLflow, which is basically a giant ledger helping you track experiments and manage every version of your model. Then there's Kubeflow, which automates your entire machine learning workflow directly on Kubernetes. And really, automation itself is a core skill here. By automating those repetitive pipeline tasks, you save tons of time, reduce human error, and radically improve your deployment consistency.
There's this great insight from our sources, and it hits the nail right on the head. Without MLOps, models work great in the lab, but they absolutely tank after deployment. Why? Because the real world changes. Consumer habits shift overnight. If an AI model was trained on data from last year, it might make terrible predictions today. This is a very real, very dangerous phenomenon known as model drift.
and it can cost a business dearly if they just ignore it.
Because of that drift, setting up continuous monitoring and logging is absolutely non-negotiable. You'll use tools like Prometheus and Grafana, which essentially act as the early warning alarm system on your dashboard. They monitor the model's performance in real time, pinging you the exact second the system starts drifting or goes down, so you can retrain the model before the end user even notices a glitch.
Finally, we wrap up with Phase 4, the career path and soft skills.
You know, it's not all just code and servers, because you will be acting as the literal bridge between data scientists, software developers, and DevOps teams. Your soft skills are just as crucial as your Python scripting. Clear communication, complex problem solving, and genuine team collaboration are what help you translate dense AI theories into business realities. Plus, in a field moving this fast, a mindset of continuous learning is what separates the good engineers from the great ones.
Master these 15 blueprint skills and the doors just fly open. You are looking at incredibly in-demand roles. You could become a dedicated MLOps engineer, a machine learning engineer, an AI solutions architect, or even a data scientist who actually knows how to push their own creations into production. Whatever route you pick, this specific blend of skills makes you uniquely invaluable to modern tech companies.
With AI so rapidly taking over everyday business operations, the blueprint is totally clear, and the tools are just waiting to be used. So as companies desperately look for talent to bring their AI out of the lab and into the real world, the only question left is, which of these MLOps paths will you take to bridge the gap between AI theory and actual real-world impact?